Hello everyone, in this video we are going to focus on primary trigonometric ratios. We're going to focus on determining side lengths, and we're also going to focus on determining angle measures. Okay, so in this first example we have a right angle triangle. The base length of x is what we need to find, and we see that the hypotenuse is 15. So step one, we need to label our sides. So 15 will form the hypotenuse. Side x is adjacent to the 70 degrees. And then we consider the ratios of sine, cos, and tangent. And the sine ratio is the opposite length over the hypotenuse, which is not in this case. The cosine ratio is the adjacent over the hypotenuse, and that is what those are the two sides that we have in this case, so we're going to use the cosine ratio, and the tan ratio would have been the opposite over the adjacent. So now that we discovered it's the cosine ratio, let's set up our fractions, and it would look like this. The cosine of 70 degrees equals the adjacent length over the hypotenuse length. And now we simply have to solve for x. So if you treat this as two fractions and you multiply the left side by 15, it becomes 15 times the cos of 70 degrees, and that'll equal length x. We've isolated x. So really you set up your fractions based on the ratio of sides that are given, in this case the adjacent and hypotenuse, and then you deal with it the same way you would deal with equivalent fractions, and you have an unknown part. So in this case we just multiplied the left side by 15 because that's the opposite of dividing by 15. Okay, so let's carry on. Next we're going to have to type cos of 70 degrees on our calculator, because all the ratios are pre-programmed in the calculator. So on my calculator, first I would type in 70 and then I press the cos button. On other calculators you might have to type it in the other way around, cos 70, and that gives me a ratio of 0.3420 ... because it continues on my screen and I don't want to round it off just yet. And then I'm going to multiply that by 15, and x will equal 5.13 ... And before I round off, I'm going to go back to the instructions, and the instructions ask for the side length to the nearest tenth. So the nearest tenth, that's the first decimal place. So therefore we're going to round this off. X is approximately 5.1 centimeters. And that concludes the first example, determining the side length in a right triangle with a missing side. We were given an angle of 70 degrees and the hypotenuse of 15. And since the missing side was the adjacent side, we used the cosine ratio. Okay, next in the second example, again we need to find the missing side length. So we begin by labeling our sides of the right triangle based on the angle of reference. And in this case, the missing side x is opposite the given angle. It's the opposite side. And the 4.6 is opposite the 90-degree angle. So that is called the hypotenuse side. And based on our trig ratios of sine, cos, and tangent, we consider which ratio, the sine, cos, or tan ratio, involves the opposite and the hypotenuse side length. And we notice that that's the sine ratio. It has an opposite and a hypotenuse. Okay, so let's set up our fraction. the sine of 61 degrees equals the missing side x, opposite, over hypotenuse. And again, we treat this like equivalent fractions. We're going to multiply by the 4.6 to isolate x, and that becomes 4.6 sine of 61 degrees. And that'll equal our missing length of x. So we're going to take our calculator, we're going to type in my case, I type in the angle first, 61, then I press the sine button. On other calculators, you might have to type in sine first, and then the 61 degrees. In either case, the ratio is 0.8746 ... It continues. I'm going to leave it on my screen. Then I'm going to multiply by 4.6. And that gives us a value of 4.02 ... The question asks us to round off to the nearest tenth. So that's the first decimal place. So therefore, it will become approximately 4.0 centimeters. And that is the side length that was missing, x, which is opposite the angle of reference. And we were given the 4.6 length. Actually, in this case, it's meters, not centimeters. So let's go back and fix our unit of, edit our unit of measure here to meters. And we were given the hypotenuse, and we had to find the opposite, so therefore we use the sine ratio. And that concludes this second example for finding the missing side length. Okay, in this next example, we're going to again use primary trigonometric ratios to find missing values in a triangle. In this example, the missing value is an angle measure. And again, we can do this in right triangles. So we notice that the side length of 9 is opposite the angle in question, the missing angle theta. And we notice that the 15 is adjacent to the angle of reference. So we set up our trig ratios. Again, we have 3 primary trig ratios. They each involve a different pair of sides. And in this example, we are working with the opposite and the adjacent side length. So therefore, we're going to use the tan ratio because it uses the opposite and adjacent side length. So let's set up our fractions. So the tan of the missing angle theta will equal the opposite length over the adjacent length. And since we have a complete fraction, we have a complete ratio of 9 over 15, and we have a missing angle, what we need to do is the inverse of the tan ratio. So it's going to become tan inverse. We're going to remove the angle and insert the ratio. And by doing that, it allows us to isolate the angle. So how do you actually calculate this now? Well, on your calculator, you need to first determine that ratio of 9 divided by 15, which is 0.6. So tan inverse of this given ratio will equal angle theta. So now, if you press the second button on your calculator or the shift button, you'll notice that above the tan button there's a tan -1 written. That's called tan inverse. So to activate it, you press second, tan, and you'll get an angle measure of 30.96 ... And the question says to round off to the nearest tenth. So we're going to round off to the 9, and that 6 is going to turn the 9 into a 0, which brings it forward to the ones. So it becomes approximately 31 degrees. So whenever you're looking for a missing angle, you will use the inverse button, which is above the primary trig buttons. So you're going to have to either press second or shift, depending on your calculator, to access that function of the inverse. And that concludes this video. We first found missing side lengths using primary trig ratios, and now we found a missing angle measure using primary trig ratios. Thank you for watching. Have a great day. Please subscribe to my channel. Leave your comments in the comment box below and I will get back to you and answer them. If you have questions that you'd like me to answer and demonstrate certain skills, please leave them and request them in the comment box below and I will get to them. Thank you and have a great day. You guys are awesome.